This tutorial is about independent samples t-test. A t-test is a statistical test used to compare the means of two groups. For example, in this fictitious data entered in SPSS, we have a variable gender with two groups, male and female, and a variable socioeconomic status. If we compare a group with two categories, such as male and female, with a non-group or a non-categorical variable, such as socioeconomic status, it would be done through a t-test, where the means of the two groups in terms of socioeconomic status will be compared to see which group has a significantly high or low socioeconomic status. Let's run the analysis with the same example. Go to Analyze, Compare Means. Under Compare Means, the third test is an independent sample t-test. Remember, the t-test is to compare the means of two groups. So the variable we have with two groups is gender. Add it into the grouping variable by clicking this arrow. Then define groups. Under define group, the value for group 1 is 1 and value for group 2 is 2. Make sure you have the same value as you entered in your gender category. So I have 2 as female and 1 as male. So these values are correctly entered. In case you have a different coding for your gender, let's say you have the binary variable with 0 and 1 response, you need to change the value in group 1 and group 2. Value 1 and value 2 are provided by SPSS by default. Click Continue. The groups are defined. Now we need to enter the test variable into the right pan. In our case, income as an indicator of socioeconomic status is the variable. I'll click the arrow and enter it to the right pan and click OK to proceed with the analysis. The first table in t-test provides descriptive statistics about the variables mean, standard deviation, and standard error mean. It also provides a sample size for each group. We have 9 males and 11 females in this group. In t-test, descriptives table is very important as the t-test is used to compare the means between the two groups, so the means for both groups will be assessed. For the current analysis, the mean for male is 33,888.88 and mean for the females is 48,272.72. Remember, we are comparing the mean of socioeconomic status between the two groups. The second important thing in t-test is one of the assumptions of t-test other than the normality of the distribution is homogeneity of variance. That is assessed through the Levene's test of equality of variance. Before concluding if there are any mean differences in the group, assumption for equality of variance must be checked first. Under the section of Levene's test for equality of variance, if the significance value of Levene's test is greater than 0.05, then the assumption for equality of variance is assumed, and the reading will be taken from the row equal variance assumed. However, if the significance value for Levene's test for equality of variance is less than 0.05, the assumption for equality of variance is violated, and the reading will be taken from the row where it says equal variance not assumed. In this case, the significance value for Levene's test for equality of variance is less than 0.05, and the value is 0.041. So the assumption for equality of variance is violated. Therefore, we'll be taking the reading from the row equal variance not assumed. From the descriptive table, we've already noticed that the mean for the females is greater than the mean for the males. In order to assess if the difference is significant, we need to refer to the significance two-tail value under test for equality of means. Under test for equality of mean, we need to refer to significance two-tail. If the value is less than 0.05, then we can conclude that there is a significant mean difference in both groups, and female socioeconomic status is significantly higher compared to males. The other important thing in t-test is the t-value. A large t-value, positive or negative, suggests a greater difference between the means. A t-value close to 0 indicates little or no difference between the means. A positive value indicates that the mean of group 1 is greater than the mean of group 2, and a negative t-value indicates that the mean of group 2 is greater than the mean of group 1. In our case, the t-value is negative 4.12 since we are taking the reading from the row equal variance not assumed, which suggests that the mean of group 2 is greater than the mean of group 1. In a nutshell, this t-test suggests that socioeconomic status of females is higher as compared to males, as indicated by the mean, and also verifying the significance two-tail value, which is highly significant. Keep in mind that before reaching to any conclusion, we need to first consider if the Levene's test of equality of variance is providing any information about the assumption, if the assumption is met or if the assumption was violated. Let's run another t-test with multiple variables. Go to Analyze, Compare Means, then under that independent sample t-test, let me add political inclination, frequency of donation, and happiness into the right pan. And we've already defined our group. Let's press OK. So in the second t-test, we are assessing the mean difference between the groups in terms of political inclination, donation or charity, or happiness. As we can see, for political inclination, the mean for females is high as compared to male, and for charity and donation, the mean for male is high as compared to female. And for the last variable, happiness, the mean for male is higher as compared to female. Let's refer to the second table for independent sample t-test. The first variable is income as an indicator, that is socioeconomic status, which we have already discussed. The second variable is political inclination. The significance value for political inclination under Levene's test for equality of variance is 0.380, so the assumption is assumed for this one. However, the results are non-significant for this one. So regardless that the mean for female is higher as compared to male, apparently a difference in mean, however, that mean difference is non-significant. Moving forward, we have frequency of donation or charity. The equality of variance assumption for the third variable is also assumed, and this time the results are significant under significance two-tail for the test of equality of means. Referring to the descriptive statistics table for donation and charity, the mean for male is 9.88 and female is 6.09. So there is a significant difference in donation and charity in male and female, and male's charity higher as compared to female. Moving forward to the fourth variable, happiness, the assumption for equality of variance where this variable is also assumed, and we'll take reading from equal variance assumed row, and the results are also significant, and the statistics table indicate that the mean for males is high, that is 19.22, and the mean for females is 13.36. So there is a mean difference in happiness in male and female group, and the results are significant, which indicates that male are more happier as compared to female with this fictitious data.